Hello, math students. Today we're going to be going over systems of linear equations. So this is when you have multiple lines and we want to see where the lines cross. We want to see where the lines coincide. And this is an important lesson because the rest of this unit will be mostly based on this concept. So if you pay close attention in the beginning, then it'll make a lot more sense as we move through the various lessons. So follow along, take good notes, and write down everything I write, and I'm sure you'll do well. I know these videos are long, but I guarantee you if you take the time, watch them, do the work, it'll make a lot more sense and it'll pay dividends later on down the road. So let's go ahead and start with the tutorial, Systems of Linear Equations tutorial. And the warm-up, let's go ahead and read it here. Suppose you have a pocket full of change. You have some pennies and some quarters. One expression could be used to describe the total number of coins in your pocket, P plus Q. So P is the pennies, Q is the quarters. So the number of coins you have is P plus Q. The second expression could be used to describe the amount of money in dollars in your pocket. So each penny is worth $0.01 and each quarter is worth $0.25. So it's 1 cent times the number of pennies and 25 cents times the number of quarters. So that's where this equation comes from. Notice that each expression describes a different characteristic of the change in your pocket. So this is kind of key when coming up with these equations. Notice the first equation has to do with the quantity of the coins, and the second equation has to do with the value of those coins. Evaluate each expression for the situation where you have 6 quarters and 7 pennies in your pocket. So in this case, what we're saying is that we have 6 quarters and 7 pennies, or 6 quarters and 7 pennies. So P is 7 and Q is 6. So if I did P plus Q, this would be 13. Okay, so P plus Q equals 13. What about this second equation? Well, this is saying 0.01 times the number of pennies. So 0.01 times 7 plus 0.25 times the number of quarters, Q, which in this case is 6. So 0.01 times 7 is 0.07 plus 0.25 times 6 is 1.50. So $1.50, which makes sense. 6 quarters is $1.50. Add those together, that's $1.57. Okay, so there we can write that there. So it's 13 and $1.57. Now, what we can do is graph these two equations. And what we should see is that the two equations cross at a point with 6 quarters, 7 pennies. So I graphed these two equations on Desmos here. X plus y equals 13 and 0.01x plus 0.25y equals 1.57. Here I'd use x and y instead of p and q, but same idea. And here we could see where these two lines cross. Notice the lines cross at 7,6, meaning 7 pennies and 6 quarters, which is exactly the numbers we used. So the location or the point where the two lines cross is always the solution to a system of equations. We'll go into more of this in detail, but just for now, know that when the two lines cross, the location of their intersection is the solution for the system of equations. All right, let's go ahead and move on. Okay, yada, yada. We can actually move along all the way to page 11 here in the tutorial. Okay, so in this activity, we'll graph systems of linear equations to find their solution. So here we're just going to graph some lines and hopefully remember from lessons previously that how to graph lines that are in this form. Notice this is in the slope-intercept form, y equals mx plus b. And if you recall, m is the slope and b is the y-intercept. Y equals mx plus b. Now, let's go ahead and graph these two equations. So for the first equation, if I'm thinking about it as terms of y equals mx plus b, this first equation, our m, or our slope, is the 3, right? Because we're thinking about it in the slope-intercept form. Y equals mx plus b. The m is always the coefficient for the x. See that? Now, our b in this first equation is -5. So our y-intercept for the first equation is -5, and our slope for this first equation is 3. So that's rise 3, run 1. So we can think of it as 3 over 1. For the second equation, I guess I'll change color here. For the second equation, my slope is what? What's my slope here? Well, hopefully you see that it's 1/2. And the y-intercept in this case is +5. So let's go ahead and graph these two lines here. We'll use this line tool. Okay, line tool. So for the first equation, I would start with my y-intercept at -5, and then I'm going to go up 3 over 1 because our slope is 3. So start at -5 on our y-intercept, then go, and you'd click and drag up 3 over 1. So this line that I just made is the graph of this first equation here. Now, let's go and graph this second line, y equals 1/2 x plus 5. So in this case, our y-intercept is +5. So on the y-axis, we start at 5. And then we go up 1 over 2 because our slope is up 1 over 2. Now, where do these two lines cross? Their intersection is right here. So their intersection looks to be at 4,7. 4,7. So where do these two cross? We'll put 4,7 right there. So make sure to put parentheses, 4,7, just like that. Okay. Coordinate points, generally, we put them in parentheses, just like that. Now let's go ahead and do this next set. Well, these equations are a little worse looking, right? Notice that what says 1.15x plus 0.65y equals 8.90. So yeah, this one's going to be kind of a pain to graph. The second one, not so bad. X minus 3y equals -15. Here you'd have to solve for y and get it in the form y equals mx plus b. But one thing we could do is, since this is a graphing tool, what you can do is just go to relationship here, go to linear, and actually, don't go to linear. Let's try going to custom. Then in custom, we're just going to put the two equations just as they are here. So the first one, 1.15x plus 0.65y equals 8.90. Go ahead and plot, and it should plot the equation for you just like that. Now let's go and do a second one just as we did the first. Go ahead and go to custom once again, and then we're going to type in the second equation. X minus 3y equals -15. Plot that, and we could see where the two lines cross. And just like that, we're done. You can see where the two lines cross. It looks to be at 4.11. I'm going to go and write that down. 4.11 and then 6.39. Okay. The lines on the graph part A don't intersect at two whole numbers on the coordinate grid. So in the first example we did, they crossed at, some nice numbers. It was like 4,7 or something, right? But this one crosses at more weird numbers, essentially, right? So estimate the values of the solution to the nearest 1/4 of a unit. So we're going to say, rounding to the nearest 1/4 of a unit, we're going to say that they cross at 4.25, 6.5. Okay. And then they want us to substitute the x and y values into the appropriate solution into the two equations. How close do you get to the constant numbers in each equation? So we're going to plug this as our x and y into each of these equations we had here. So actually, I'm just going to copy and paste these down here. And what we're going to do is for this one, we're going to replace, for both these equations, we're going to replace x with 4.25 and then replace y with 6.5. So let's go ahead and do this first equation first. So 1.15 times x, so that's times 4.25. Notice I just put it a number in front of parentheses like that. That just means they're multiplied. Okay. Plus 0.65 times the value of y, which 6.5 is our value of y. And we want to see what does this end up equaling. So I'm going to just use the calculator here. 1.15 times 4.25. Okay. Plus 0.65 times 6.5. And I got 9.1125. And we could say, notice it's not exactly what we wanted. We wanted 8.9, right? So our estimate's a little off, which kind of makes sense because we didn't find the precise values for x and y. But we could say something like our estimated value is a little off from the value, I'll put in parentheses here, 8.90 that we were looking for. Okay, now let's try the second equation. So what we're going to do is replace, once again, x and y with the same two coordinate points. For x, 4.25, and for y, 6.5. So 4.25 minus, and then it's 3y there, so 3 times the value of y, 6.5. And then we want to see what this equals. So 4.25 minus 3 times 6.5. So this gives us negative 15.25. So this one's pretty close, right? We could basically just say this again. But I'll change this value to negative 15. All right. That looks pretty good. All right. Once you're done with that, let's move along. All right, so this one's very similar to what we just did. We basically have two equations. We want to graph them here. So graph the lines of the two equations and mark the point of intersection for the two lines. And approximately how many minutes will the two planes be at the same altitude? At what altitude will they be? So if we read the situation here we're talking about two planes that are flying. Plane A is descending, going down, towards a local airport at a rate of 2,500 feet per minute. It is currently at an altitude of 12,000 feet. Plane B is ascending, going up, from the same airport at a rate of 4,000 feet per minute. It is currently at an altitude of 1,000 feet. So we have these two systems basically because of that. We can see for the plane A, this is in thousands of feet. So 12 represents the 12,000 feet of altitude. And it's descending, so minus, it's descending 2,500 feet per minute. Similarly, the second equation, starting off with an altitude of 1,000. So that's where this 1 comes from. And then it's ascending or going up. So that's why it's plus. And it's going up 4,000 feet per minute. Okay, well, let's go ahead and graph these two lines. In actuality, I'm going to rewrite these equations a bit so that they're in the y equals mx plus b form. This is the slope-intercept form. And let's go ahead and write these equations accordingly. So instead of 12 minus 2.5x. I'd rather write it as y equals negative 2.5x. And then plus 12. Notice the negative sticks on the 2.5x. Okay. Now we can see that, oh, the slope, or our m, is negative 2.5, and our y-intercept is 12. So when I put it in this form, it's perhaps a little bit easier to see what's happening and what we're to expect from the equation. Similarly, I could write this equation as y equals 4x plus 1. Now we can see our m, our slope, is 4, and our y-intercept is 1. So let's go ahead and graph these relationships. Here we could just say linear, and our, well, I don't like this. Let's just go to custom again. And the first one was y equals negative 2.5x plus 12. Let's go and plot that. All right, and we can see the equation. We can see the graph there. Let's do the next one. Y equals, and what was it? 4x plus 1. Plot that, and we can see where the two lines cross. It looks to be at 1.67, comma 7.75. About. Okay, let's see what they have as an answer. 1.75, 7.75. Okay, that's about the same. But what does this intersection tell you? Well, it tells you the x and y coordinates. The x coordinate was the amount of time. So how long or at what time will they be at the same altitude? Well, at about 1.67 minutes, or 1.75 minutes is what they got. Just an estimate. And then the second coordinate, the y coordinate, tells you the altitude that they will be at the same. So 7.75 thousand will be the altitude where they're at the same altitude, right? So it tells you the time when they'll be at the same altitude, and it tells you that altitude. So it answers the coordinate where they intersect, tells you both these questions. In approximately how many minutes? 1.75 minutes. And at what altitude will they be when they are at the same altitude? That'll be 7.75 thousand for the altitude. A couple things to keep in mind. Sometimes you have parallel lines. And if we're looking for the intersection of parallel lines, well, as we know from previous lessons, parallel lines don't cross each other. So if you have parallel lines and we're asking, oh, where do they intersect? Well, the answer is they don't intersect. So this system would have no solution, right? So if they have parallel lines, in other words, the two equations have the same slope, then they will have no solution in their no intersection, right? No solution. Most of the time, though, we'll have one solution. So that's where the two lines cross. The intersecting point is the solution to the equation. Here we can see these two lines graphed here, and they intersect at 2, 1 in this case. The other situation you may have, which is also kind of rare, is that the two equations are actually the same exact equation. They're just written differently. So if the two equations actually produce the same line, then they actually have infinitely many solutions, because the two lines are the same line. They're actually crossing each other at every point. So they're constantly crossing each other, constantly intersecting. All right. So here it just talks about the number of solutions. In this, we could look from this graph. How many times do these two lines cross? Well, they cross just once. So here we'll put one solution for this first system. The second system, here they're parallel lines. So how many times will they cross? Well, they don't cross at all. So no solution for them. These two lines, you can see they are crossing each other. It looks like at 6, 0. So they do have one solution where they cross. This last one, the two lines are actually the same line. So they are constantly touching infinitely many times. Hope that made sense. All right, now for the rest of this lesson, you're going to need this piece of information here. Okay, so go ahead and read it to yourself. I'm also going to, or follow along as I read it. Imagine you're going to be on a TV quiz show called 20 Questions. The show's grand prize is a trip to Hawaii. Yay. And you desperately want to win. On the show, each contestant is asked 20 questions and earns or loses points as shown. So you earn 100 points for each correct answer. 200 points lost for each incorrect answer. And no change in points for not answering the question. So like in this game, if you really don't know the answer, you should just not submit an answer, right? Because if you get it wrong, you lose 200 points. But if you don't say anything, you don't submit an answer, then you don't gain or lose points. So sometimes it's better just to not answer in this game. While watching a recent episode, you notice that the reigning champion, Kimberly, responds to all 20 of the show's questions, but isn't always right. When the game ends, she has a score of 500 points. Okay, so she answered all the questions, but a lot of them she answered wrong. So she only scored 500 points when answering all 20 questions. Okay, so let's go ahead and look at this scenario here. By analyzing past episodes of the quiz show, I'm on page 19, by the way, of the tutorial, you realize that you probably need 600 points to defeat Kimberly, which makes sense because she scored 500. Kimberly scored 500. So if you get 600, you'll beat her. All right. You also notice that on average, you only feel confident enough to respond to 12 of the 20 questions on a typical episode. So if you respond to only 12 questions when you're on the show, which two equations describe your winning scenario? So first of all, it doesn't talk too much about this, but think of X. X is the number of questions you get correct. All right, so this is important. X is the number of questions you get correct. Y is the number of questions you get wrong. So Y is the number of questions you get incorrect. All right, so we know that the number of points you need to score is 600. So the way your points are calculated are just like this. You get 100 points for each correct answer, and you lose 200 points for each wrong answer, and you need 600. So this is the equation for the number of points you're going to need to win. Also, you're only going to be answering 12 questions, right? You only feel confident enough about 12 questions. So if we take the number of questions you get right plus the number of questions you get wrong, X plus Y, and you add those together, that would be 12 questions that you're responding to. So those are the two equations for this system of equations. Let's move on. Now let's go on to page 23. Here we're dealing with the exact same problem, okay? Let's see what it would take to win the trip to Hawaii. Remember that you think you'll respond to 12 questions and hope to score 600 points to win, although it's possible to score even more points or many fewer, including negative scores on the show. So if you get all your answers wrong, then it's possible to just get a negative score. That's possible in this show. It's kind of like Jeopardy, right? You can get a negative score in Jeopardy. Here are the equations you wrote to model the winning scenario. This is the same two equations we got from the previous page. X plus Y equals 12. That's the number of questions. And then 100X minus 200Y equals 600. So that's the final score that you're hoping to get. Are the boundaries of the first equation viable in the second equation? What does this suggest about your plan to score 600 points? Select two correct statements. Okay. So the couple things you can think about is the fact that X plus Y equals 12. So it's possible that X is 12. In other words, you get all 12 questions right. And then y would have to be 0 there because they add up to 12, right? X plus y equals 12. So if x is 12, y would have to be 0. Well, in this case, what would be your score? Well, to calculate your score, you would do 100 times 12, right? Because you get 100 points for each correct answer. So in this scenario, your score would be 1,200. Okay. Now, it's also possible that you get all your questions wrong. So you answered 12 questions, but this time all the questions are wrong. So that's the other, what we would call the other boundary, right? So in this scenario, what would be your score? Well, this score, you lose 200 points for every incorrect answer. So that would be negative 2,400, right? 12 times negative 200, basically. Okay, so these are your boundaries, possible scores you can get if you answered 12 questions. Okay. So the boundaries of the first equation result in scores of negative 2,400 and positive 1,200, which are both viable. That's correct. The lower boundary of the first equation is not viable because there can't be negative scores. Well, that's wrong because we know there can be negative scores. The actual other correct answer is because 1,200 is greater than 600, there's probably a way to score 600 points and win even with a wrong answer or two, right? Which makes sense. If you'll have to get most of your questions correct if you want to score 600, but since our upper boundary is 1,200, it's likely that you could get like 10 of them correct and then miss a couple and still win, right? That's what this last one says, basically. Okay, kind of a funky way to present that, but okay, well, that's the tutorial. Let's go ahead and work on the practice. Now you're going to be offered 5 questions from the practice. There'll be 5 of these 10 questions. I have 10 questions. Just follow along and do what I do and write down what I write and listen to the things I say, and you'll do well. By the way, if you're not subscribed already, you should do so. Okay. Eve is organizing a race to raise money for a local children's hospital. She makes $20 for each 5K participant and $45 for each 10K participant. Her goal is to raise $9,500. By the way, 5K and 10K, those are just distances. So those are the types of race. Those numbers aren't going to be actually important to the equations. If X represents the number of participants in the 5K race and Y represents the number of participants in the 10K race, the linear equation for the given scenario is, well, if X is the number of 5K racers, right? X is the number of 5K racers, and she earns $20 for each 5K racer. So it's $20 times the number of participants in the 5K, $45 for each of the participants in the 10K, and the resulting amount of money, $9,500. If Eve raises exactly $9,500, is it possible that there were 220 participants in the 5K race? So for that, we're going to look at our equation here. So our equation, 20x plus 45y equals 9,500. We're going to see if this is a viable solution. So the x is the number of 5K participants. So in this case, 20 times x becomes 20 times 220, because 220 is the number of 5K participants, plus 45y equals 9,500. Now let's go ahead and multiply the 20 times 220. So that's 4 4, 0, 0 plus 45y equals 9, 5, 0, 0. So I want to go ahead and solve for y. And ideally, what we're looking for is for y to be a whole number value. We wouldn't want y to be a decimal in this case, because you can't have like 0.5 of a participant. Participants in this case need to be whole numbered values, positive whole number values. So let's solve for y here. So get y by itself. So that gives us 45y equals, and this is 5, 1, 0, 0. Divide both sides by 45 in order to get y by itself. Gives us that y equals, and let's see if this divides evenly. So I got my calculator here, 5100 divided by 45. I got 113 and then 0.3. The 0.3 repeats forever. So this is not a viable solution. So it's not possible for her to earn exactly 9,500 and to have 220 participants in the 5K. So it's not possible for both those things to be true at the same time. Okay. Using drawing tools to form a correct answer on the provided graph the lines that represent the following linear equations. So the first equation is 2x plus 1.5y equals negative 60. So we want to get both of these equations actually into the slope-intercept form to help us graph it. So remember, the slope-intercept form is y equals mx plus b, right? So how do I get this into that form? Well, actually, that's just right here. Y equals mx plus b, where m is the slope, b is the y-intercept. So how do I get this first equation into this form? Well, what we want to do is solve for y. Now, one of the things I'm noticing here is this 1.5. I actually don't like to use that. I'd prefer if it was just a fraction. So we're going to actually change this 1.5 into 3 over 2. 3 over 2. Now, the reason 3 over 2 is what we're changing it to is because 3 over 2 actually equals 1.5. If you can check in your calculator, 3 divided by 2, and it'll give you 1.5. So 3 over 2 is 1.5, and I can replace it with a fraction just like that. So to get y by itself, the first thing I'm going to do is I'm going to go ahead and subtract 2x on both sides of the equation. Remember, whatever we do to one side of the equation, you have to do to the other side. So our equation now looks like 3 over 2 y equals negative 2x minus 60. From here, let's go ahead and multiply both the equations by 2 to get rid of this denominator. So multiplying by 2 gets rid of that. So that's good. But that means you have to multiply this side by 2 as well. So here we'll have 3y equals, let's distribute this 2. So it multiplies with every term in there. So negative 4x minus 120. Lastly, to get y by itself, we're going to divide both sides of the equation by the coefficient there, 3. So divide by 3, divide by 3, divide by 3. Okay. Remember, whenever you multiply or divide by something in an equation, you have to multiply every single term by that. Okay. And there we go. So this first equation is y equals negative 4/3 x minus 40. So since minus 40, I'm going to put a point right here. And it's down 4 over 3. Down 4, well, I'm going to be off the chart here. So I don't normally do this, but I'll have to go up and left. 1, 2, 3, 4 over 1, 2, 3. If I'm looking from this point to start, you'd go down 4 over 3 to get here. So it is correct And then you would use the line tool to go ahead and draw the line connecting these points. Should see something like that. For the second equation, it's quite a bit simpler. I'm actually going to write it over here. So it's 2x plus y equals negative 50. Now our goal is the same. We want to get y by itself. So what am I going to do here to start? Well, I'm going to subtract 2x. And I'll have to subtract 2x over here as well. Whatever you do on one side of the equation, you have to do the same thing on the other side of the equation. Okay, so negative 2x minus 50. So negative 50. And then negative 2x, that's negative 2 over 1 essentially for our slope. So down 2 over 1. But I'm actually going to go up 2 and to the left 1. And these two will cross somewhere around here, something like that. My graph is not perfect, but yours will be because you're going to be using the line tool. All right. Then wherever they intersect, you're going to go to the mark feature, click on that, and you're going to put that point wherever they cross. Okay. Mrs. Lang is 4 times as old as her daughter, Jill. The sum of their ages is 60 years. So in other words, when you add their ages, it's 60 years old. Set up the 2 equations that can be used to find each of their ages. So the 2 equations, basically, Mrs. Lang is 4 times as old as her daughter. So Mrs. Lang, we're going to have it be y, and her daughter's age, Jill's age, is going to be x. So Mrs. Lang is going to be like equals. So Mrs. Lang is 4 times, so 4 times x. So that's our first equation. Y equals 4x, where y is Mrs. Lang's age and x is Jill's age. The sum of their ages is 60. So what does that mean? That means if I add Mrs. Lang's age plus Jill's age, the sum is 60 years. Okay, I hope you're writing this all down. So these are our 2 equations. So constraint 1, the solution must satisfy the ratio of their ages. So Mrs. Lang being 4 times as old. The solution must satisfy the sum of their ages. So their sum must be 60 years. Okay, only constraint blank would be met if Mrs. Lang is 32 and Jill is 8. So if Mrs. Lang is 32 and Jill is 8, well, then this is true, isn't it? Right? That Mrs. Lang is 4 times as old as Jill, right? Because 32 is 4 times as big as 8. So constraint number 1 is met here. However, constraint 2 is not, because 32 plus 8, well, that does not add to 60. That only adds to 40. So now, what about if Mrs. Lang is 45 and Jill is 15? Well, in this case, they do add up to 60, don't they? Right? So constraint 2 is satisfied. However, in this case, 45 is not 4 times as big as 15. So even though it fits the first equation, it doesn't fit the second equation. So these are not their correct ages because it doesn't fit the second equation. And then these are not their correct ages either because it doesn't fit the first equation. Okay. Remember, the correct solution would fit both equations perfectly. Next question. Determine which situation could be represented by the system of linear equations given below. 2x plus 4y is 160, and x plus y equals 50. All right. So one of these word problems could be set up using these equations. So I'm looking at this x plus y equals 50. This kind of tells me that I'm going to see like, oh, this plus this, their sum is 50, or together they add up to 50 or something like that. Okay, let's go ahead and take a look at these problems and figure out which one makes the most sense. 2 principals and 4 teachers donated a total of 160 cans of soup to the school can drive. Okay, the 2 biggest donors gave 50 cans between them. No, this is not correct. Kevin bought 2 pairs of jeans and 4 shirts at the mall. He spent $50. This doesn't seem correct either. An ice cream shop sells sundaes $2 each and cones $4 each. All right, this looks pretty good. They made $50 over the course of 2 hours. No, if they said they made $160, then that would be more correct. It must be the last one. Let's see. Jane sells beaded bracelets $2 each and beaded necklaces $4 each. She sold 50 pieces. Okay. And she made 160. Yep. So this first equation, so this is correct, because it's $2 times the number of bracelets plus $4 times the number of necklaces gave her total money, right? The total profit, which was $160. Then it also says that the number of bracelets plus the number of necklaces was 50, right? She sold 50 pieces. So that's definitely the correct answer there. On a television game show, contestants earn 5 points for each correct answer, but lose 2 points for each wrong answer. So correct answers, I'm going to say is X. Wrong answers, we're going to say is Y. So for this first part, we could say that they earn 5 points times the number of correct answers. Plus, well, actually, let's not do plus, let's do minus. They lose 2 points for each wrong answer. On last week's show, the winning contestant earned 80 points. So this is the number of points. Okay. And they answered 30 questions. So the number of questions answered was 30. So if I take the number of right answers plus the number of wrong answers, that should be 30 questions. So these are our 2 equations here. Using the drawing tool. So here it's very similar to the one we did above, where you're going to use the line tool. And to use the line tool, you just kind of click on one point, drag to another point, and then it creates the line automatically. So, but it does require like click and drag. And then you're going to mark where the 2 lines intersect. So Melinda sold packages of gourmet coffee, X, and pastries, Y, at her school fundraiser. The packages of coffee sold for $6 each, and pastries sold for $4 each. So I can kind of already see my first equation is going to be 6 times the number of pastry, or times the number of coffees, plus $4 times the number of pastries. At the end of the fundraiser, she had sold 2 more packages of coffee than pastries and made a total of $72. So the amount of money she made was $72. Now, the second equation has to do with the fact that it says she sold 2 more packages of coffee than pastries. So 2 more coffees than pastries. So if I take the number of coffees and I take away 2, that should be the number of pastries. Okay. Create and graph the system of linear equations that model the situation, then use the mark tool to indicate the solution to the system of the graphs. Okay, so once again, what we're going to have to do is get y by itself in both these equations. The second equation is actually already done for us because y is already by itself. However, I'm going to rearrange it and put y over here on the left side. So it'll be 1x, or just x, minus 2. So here in this case, your slope is 1, or in other words, up 1 over 1. And your y-intercept is -2. So how would I graph that? Well, it's kind of a pain here because we don't have negatives. But let's see. We'll graph this one in a bit. Let's actually do this first equation here we'll do the first equation first. So my goal here is to get y by itself. So I'm going to subtract 6x, both sides of the equation. So that's going to give us 4y equals, and then it's negative 6x plus 72. Then divide both sides of the equation by 4 to go ahead and get y by itself. Y equals, here we can simplify this fraction by reducing by a common factor of 2. So negative 3 over 2x. I divided both numerator and denominator by 2 to get this. Plus 72 divided by 4. I believe that's 18. Yeah, 18. So let's go ahead and actually graph this first one first. So our y-intercept is 18. Then from there, we go down 3 over 2. Down 3, 1, 2, 3 over 2. And you can continue that down 3 over 2, and you'll produce this first equation. Something like that. Now for this first equation, notice my y-intercept is -2, so that kind of makes it a bit of a pain to graph because my y-axis stops at 0 here. So one thing I could do is just get a couple of test points. So let's say I replace using like a t-table. So I could choose various values for x. So let's say x is a value of 2. So if x is 2, this would be 1 times 2, which is 2. 2 minus 2, which is 0. So 2 comma 0. And then I could replace x with something else. Maybe I'll replace it with 3. 1 times 3 is 3. 3 minus 2 is 1. So I know it goes through 2 comma 0 and also 3 comma 1. And it goes like this because it has a slope of 1. So it looks like they cross at around here. Yeah, which is at 8 comma 6. And I know this is correct because it fits both the equations. Notice if I replace x and y with 8 and 6, it'll produce a true statement for both equations. Here we have 2 equations. All right, let's see. How do you pronounce this person's name? Giles is making tacos for dinner and bought some beef and chicken. At the store, he bought twice as much beef as chicken. The chicken costs $1.85 per pound, and the beef costs $3.70 per pound before sales tax. Giles spent a total of $12.95 on beef and chicken. The system of equations below represents the pounds of chicken, x, and the pounds of beef, y, that Giles purchased. So we can see we got these 2 equations here based on the information. Use the ray tool to graph the system of equations on the coordinate plane. Use the point tool to select the approximate pounds of beef Giles purchased. All right, so basically we want to graph these 2 equations. This first one is quite simple. Y equals 2x. So our slope is 2 and our y-intercept is 0. So from 0, then up 2 over 1, up 2 over 1, because the slope of 2 is 2 over 1, essentially. Okay, now be careful here. We're counting by, up 2, you have to go up to here over 1. So this is our first equation. Make sure to use the ray tool. You would click here and drag in this direction. The second equation is quite a bit more of a pain. Let me go ahead and graph this on Desmos here, I would say. So I've got 1.85x plus 3.7y equals 12.95. I'm just going to graph it here on Desmos. 1.85x plus 3.7y equals 12.95. Okay, so it goes through 0, 3.5, and then another corner point is 7, 0. Okay, so then when I go ahead and graph it, we know it goes through 0, 3.5. So 3.5 is right here. I'm going to use a different color, maybe green. 3.5, 0, 3.5, and then 7, 0 right here. And you could use the ray tool to go like that. And then you would use the point tool to put their intersection. We can see their intersection looks to be about 1.5, maybe 1.25, maybe. I think 1.25 is most likely the closest estimate. You'll have to be the judge. It might be 1.5, 1.25. Graph the following system of equations in the coordinate plane. Use the mark feature tool to indicate the solution on the system of the graph. Okay, so for this first equation, I want to get it into the slope-intercept form, y equals mx plus b. So I'm going to start by subtracting 3x on both sides of the equation. Subtract 3x, subtract 3x. So that's going to give us negative 2y equals negative 3x minus 12. Then go ahead and divide both sides of the equation by negative 2 to get y by itself, giving us that y is a negative over a negative makes positive. So we could just say positive 3 over 2 x. And then negative 12 over negative 2 is plus 6. From here, let's go ahead and graph it. So we know our y-intercept is negative 6. Oh, that should have been a positive 6, shouldn't it? Good thing I caught it, because a negative over a negative makes positive. So hopefully some of you guys noticed that as well. Positive 6 for our y-intercept. And then from there, we're going to go up 3 over 2. Up 1, 2, 3 over 2. So our line, you can just click here and then drag to this point, and it should create the line for you. Something like that. The second equation, y equals 4x plus 1. Here, the y-intercept is 1. And then our slope is 4 over 1. So from here, we're going to go up 4, 1, 2, 3, 4, and over 1. 1, 2, 3, 4 over 1. Okay, so I can see already where these two lines are going to cross each other. Their intersection would be right here at, looks like 2, 9. Okay, make sure to put that point there on the intersection. Last question for the practice. Beth is tracking how many miles she walks in a week. Currently, she has walked 1 mile and plans to walk at a brisk pace of 5 miles per hour for the rest of the week. Her brother, Jonathan, is also tracking the miles he walks in a week. He has already walked 3 miles and plans to walk at a slower pace of 3.5 miles per hour for the rest of the week. The system of equations below represents the miles, y, walked by Beth and Jonathan in X hours. Okay, so the first equation represents from Beth because she's already walked 1 mile and she plans on walking 5 miles per hour for the rest of the week. The second equation is the equation for Jonathan. He's already walked 3 miles and he plans to walk 3.5 miles per hour for the rest of the week. Use the ray tool and graph the system of equations on the coordinate plane. So these two equations, fortunately, are they're already in the slope intercept form, y equals mx plus b. So should be relatively easy to graph. However, Jonathan's equation, notice it's 3.5. I hate mixed numbers. So 3.5, we're going to go ahead and change this to an improper fraction. And what this is as an improper fraction is what you kind of do is you take the whole number, multiply by 2, and then add the 1. So 3 times 2 is 6, add 1, so that's 7/2. So 7/2 is the same as 3.5. Okay, so I'm actually going to think of this equation as 7/2 x plus 3. So in this case, our slope is 7/2 and our y-intercept is 3. Okay, but let's go ahead and graph Beth's equation first. This is a slope of 5, or in other words, up 5/1. And our y-intercept is 1. So our y-intercept is 1. And then from there, we go up 5/1. 1, 2, 3, 4, 5/1. And you can continue that way as well. 1, 2, 3, 4, 5/1. So this is Beth's equation here. Okay, great. A very steep slope in this case. Now let's go ahead and graph Jonathan's equation. So our y-intercept, his y-intercept is +3. He's already walked 3 miles. And then his slope is 7/2. So we're going to go up 7/2. 1, 2, 3, 4, 5, 6, 7/2. So his graph looks something like this. And we can see about where these two lines cross, somewhere around here, which is, let's see. Use the point tool to select the approximate amount of time Beth and Jonathan will each. I think I messed up. Yeah, I messed up. Okay, that's all right. So one thing to keep in mind is that, let's go back and draw Beth's equation first here. So one thing to keep in mind is up 5/1. So up 5 miles over 1 hour. Here I only went over 1 like this, but actually 1 is right here. So I should have went up 5 over all the way to the 1 like this. So one thing to keep in mind is you really have to pay attention to the scaling on some graphs. Okay, and this is one of those scenarios. So I want to go up 5, 1, 2, 3, 4, 5 over 1. That puts me all the way out to here. Okay, because that's where the 1 is. So then up 5, 1, 2, 3, 4, 5 over 1. That's right here. Okay, so this is actually Beth's line. Hopefully some of you guys might have caught that. If you did, good job. Okay, it's not bad to make mistakes. I do want to emphasize that. It's nothing to be ashamed of. I make mistakes all the time. That's why I don't edit them out. And then for, what's his name? Jonathan, up 7/2. 1, 2, 3, 4, 5, 6, 7. And then over 2 is all the way out to here. Okay, so his graph looks something like this. Hopefully yours looks better because you're going to be using that ray tool. And then where do they cross? Somewhere around here. So above 1 hour, maybe like 1 hour and 15 minutes. So 1¼ hours, I would say. That's probably my best estimate. Okay. What is this? Okay, I missed a question somehow. Oh, interesting. Okay, so somehow question 6 ended up down here. I'm not sure how that happened, but let's go ahead and describe the solution of the system equations, graph below. All right, the system has a unique solution at 1, 2. No, that's not correct. It's not 1, 2. It's right here. One solution at 2, 1. System has a unique solution at 2, 1. Okay, remember, if it has no solutions, that only happens when the lines are parallel. And infinitely many solutions is when the two lines are perfectly on top of each other. Okay, now that's not the case here. Here they clearly intersect at a point, and that point is the solution. Okay, now let's go on the mastery test. One thing I want to say is that if you're not subscribed already and you're a returning viewer, you really should subscribe. It'll be a great way to help me out. On top of that, feel free to comment any questions you have below. And if you really want to say thank you, share this content with someone else. And I'm sure they'd appreciate it, and I truly appreciate it. Okay, let's go ahead and start. You're going to be offered 5 of these questions from the mastery test. Here I have a sample of, I have 20 questions, but you'll be given a sample of 5 questions from these 20. So each of you will be given different questions, but if you just follow along, I'll go over every single one of them, or at least give you a hint on every single one of them to help you out. All right, which system of equations is satisfied by the solution shown by the graph? Okay. So one thing I've noticed is that these points, or the intersection point, is the solution. So in our case, our solution is -2, 8. So that tells us that whatever system should go through this coordinate point, -2, 8. So let's just check. I'm going to go ahead and check this one here. So if this is the correct answer, then that means if I replace x with -2 and y with 8, it should produce a true statement for both equations. Well, let's see. So I'm going to go ahead and start with the first equation. It says x plus 2y equals 6. So I'm going to use x -2 plus 2 times y. The y is 8. And I'm hoping to get 6. Would this give me 6 in this scenario? Well, let's see. -2 plus 16. Does that give me 6? Well, no, it does not. So that means this is not right, which means this is not right. Okay. The correct solution should work where you plug it into both equations and it produces a true statement in both equations. So see if you can find that. Which set of coordinates satisfies this equation? So in other words, here, where do the 2 lines cross each other? You can see in the graph where the 2 lines cross. So which coordinate point is that? Which coordinate pair is the best estimate for the point of intersection? So what is the best estimate for this? Well, if you think of this as 1 and this as 2, this looks like 1.5, comma, almost 1. So see which one that makes the most sense for. 1.5, comma, almost 1. The graph system represents the rate at which 2 trucks are being filled, where x represents the time in minutes and y represents the percentage filled. Okay. Which statement is true? The solution is a non-viable because the percentage filled cannot be negative. Y represents the percentage filled. X represents the time in minutes. Okay. So you can see where they cross. They actually cross at an interesting point, don't they? They cross at -4, 0. So -4 is the x, which they're saying that x represents the time in minutes. So it's saying -4 minutes. Okay, that seems weird, right? So that's part of the reason why this is not a viable solution, because can you have -4 minutes? Okay. Here, the system of equations is shown on the graph. So here, both the equations are the same line. So both equations are actually graphed, but you only see one line. That's because both equations are actually the same line. They're on top of each other, basically. So how many solutions does that have? Does it have just one solution? Does it have no solution? Or does it have infinitely many solutions? So remember, no solution is like where they don't touch. A single solution is where they touch at that location. And then many solutions, or infinitely many solutions, means they're constantly touching. A company sells 2 versions of an antivirus software. The home edition costs $23.50 and the business edition costs $58.75. Last week, the company earned $29,668.75 from selling 745 copies of the software. If X represents the number of copies of the home edition, so the home edition is X, and Y represents the number of the business edition, so business edition is Y, which system of equations represents this situation? So we're going to create two equations. One of them has to do with the money, and the other one has to do with the quantity. So in this case, they sell the home edition, $23.50 times the number of home editions, so times X, plus they earn $58.75 times the number of business editions they sell. Should this give you the amount of money they earned, or should this give you the number of copies? Also, when we look at the quantity, the number of home editions plus the number of business editions is how many editions. So should that be the money or the number of copies of software? Okay, think about that. Number 7, determine which situation could be represented by a system of linear equations given below. A guitar requires 5 strings and a banjo requires 3 strings. The orchestra has a total of 220 strings. No, that's not right. A candy store sells boxes of chocolates for $5 each, boxes of caramels for $3 each. In one afternoon, the store sold 220 boxes. No, that's not right. An art teacher bought paintbrushes in packs of 5 and of 3. She bought a total of 60 packs and now has 210 paintbrushes. Yeah, this is the correct one. If the graphs of the linear equations in a system are parallel, what does that mean about the possible solutions? Remember, parallel lines, they don't cross. So what would you say about their intersection? So here we have these two equations. We have them graphed here. What is the solution here? Well, it looks like it's between -4 and -3 here. So maybe -3 point something for the X. And then for the Y, it's between 2 and 3, right? So comma 2 point something. Okay. So I know it's negative something, then positive something. And if I plug into my calculator, so knowing that the first number should be negative and the second one should be positive, I know that's either this one or it's this one, right? Okay. Now, looking at answer choice B, if I do 13/4, that gives me 3.25, -3.25. So it seems like this is the correct answer here. 5/2 is 2.5, which, yes, on the y-axis, 2.5 looks correct. By the way, to change a fraction to the decimal, it's very simple, just using the calculator. So like 5/2, you would just do 5 divided by 2, and then it'll change it to a decimal for you. The concession stand at the high school football stadium sells hot dogs and hamburgers to raise money for the high school athletic program. Each hot dog sold earns 50 cents. Each hamburger sold earns 75 cents. This week, the concession stand sold a combination of 230 hot dogs and hamburgers and earned $138.50 for the athletic programs. If X represents the number of hot dogs, all right, so hot dogs is X, so that must mean hamburgers is Y. Okay, so there's two equations. One has to do with the values of the items. So it's 50 cents times the number of hot dogs, plus they earn 75 cents times the number of hamburgers. This should give you the amount of money they brought in. in total. Also, if we take the number of hot dogs sold plus the number of hamburgers sold, this should equal the total number of hamburgers and hot dogs they sold. Okay, so looking at these numbers here, where should they go in these equations? Let's try to figure that out. One of them has to do with the values of the items, and the other one has to do with the quantity of the items. Estimate the solution for the system following equations by graphing. Okay, so what I would do is probably just graph these on Desmos. So I'll just go to a graphing calculator and graph them. So my equations are 3x plus 5y equals 14, and then 6x minus 4y equals 9. So using Desmos, which is this website here, desmos.com, you could just graph the two equations. So 3x plus 5y equals 14. So there's our first equation. And our second equation was 6x minus 4y is 9. So where do these two lines cross? Okay. You can see that there. Okay. So what would be the best estimate using these? So remember, to change fraction to a decimal, you would just divide. So for example, 7 over 3, you just do 7 divided by 3. Okay. Yeah. Amanda is placing an order for running shoes and leather boots for her footwear boutique. She needs a total of 48 pairs of shoes and twice as many pairs of running shoes as leather boots. Okay, so if I take the number of, so running shoes we'll say are X, leather boots are Y. If I do X plus Y, that should give us 48 pairs of shoes, because it says she needs 48 pairs of shoes. And she also needs twice as many pairs of running shoes as leather boots. So if I, the number of running shoes is twice the amount of leather boots. Okay, so we set up the two equations. Let the equation that represents the total number of pairs of shoes be referred to as constraint 1. So this is constraint 1. And the second equation is constraint 2. Only constraint blank would be met if 18 pairs of leather boots and 36 pairs of running shoes were ordered. So if I looked at these two numbers, which of these constraints is being followed here? Well, do they add up to 48? If they do, then they are meeting constraint 1. If the running shoes are twice as much as the leather boots, then that's constraint 2. Okay, and use the same logic to figure out whether this is constraint 1 or constraint 2. Here. This one's very similar to the last one. Mrs. Rodriguez, or Ms. Rodriguez, purchased markers to be used in a class whiteboard. She bought a total of 16 markers and 3 times as many blue markers as red markers. So we'll say there's blue markers are X, red markers are Y. If I take the number of blue markers plus the number of red markers, that's 16 markers. Okay. Also, it says 3 times as many blue markers as red markers. So if I take the number of blue markers are 3 times the amount of the red markers. Okay. The constraint 1 referred to the total number of markers. So once again, this is constraint. The first equation is constraint 1. The second equation is constraint 2. Only constraint blank would be met if Ms. Rodriguez has purchased 3 red markers and 9 blue markers. So 3 red markers and 9 blue markers. Does that follow constraint 1 or constraint 2? What about if she purchased 6 red markers and 10 blue markers? Does that follow constraint 1 or constraint 2? Use the drawing tools from the correct answer on the graph. Graph the system equations on the coordinate plane. And then we want to use the mark feature to show where the two lines intersect. This first equation is already in a great form that we like, y equals mx plus b, which is the slope-intercept form. In this case, your slope is your m, your 4/3, and your y-intercept is 4. So, and for the second equation, it is not in this form yet. What we need to do is divide by 3 on both sides of the equation, divide every term by 3 to cancel out this 3 on the coefficient of y. So y equals negative 2/3 x minus 2. So for this second equation, you would use a y-intercept of negative 2 and a slope of down 2 over 3. Then you would graph the two lines and see where they cross. This one's the same idea as the last one, actually. Here for this first equation, your slope is negative 3. You can think of it as negative 3 over 1. So to graph this line here, you would take the y-intercept of 3. That's from this, 3. And then you'd go down 3 over 1. So down 3 over 1. Use the line, click and drag from here to here, and then that should create your first line. See if you can draw the second line and see where the two lines cross. This one should look like this. Okay. Use a system of equations to graph and graphs below to complete the sentence. Okay, x minus 2y equals 5. 3x plus 15y equals negative 6. So I'm going to go ahead and look at this first equation here. I'm going to go ahead and solve for y in order to get this in the y equals mx plus b slope-intercept form. So the first thing I would do is subtract x on both sides of the equation. So that'll give me negative 2y equals negative x plus 5. Then divide both sides of the equation by negative 2 in order to get y by itself. So that'll give me y equals negative over negative. That makes positive 1/2 x. And then this is negative 2.5 or 2.5. So which graph has this as one of the graphs? Negative 2.5, then up 1 over 2. Negative 2.5, up 1 over 2. So this blue line looks like it matches that. This one does not. Looks like it went up 1 over 4 or something. So I think this is the only one that has the actual line we're looking for. So I don't have to graph the other one, but I can assume that this red graph is this one here. Now, where do these two lines cross? It looks like they cross at this coordinate point. So we would say graph B, and then tell me the x and y coordinates or where they cross. Match each system of equations to its point of intersection. Okay. Well, I think I'm missing half my question here. But that's okay. One thing you could do is I could just go ahead and graph these two equations on Desmos. So I can go back to Desmos. That's desmos.com. It's a great graphing calculator. And I can just graph these two equations and see where their intersection would be. So the first equation, y equals 2x plus 1, then y equals x plus 3. So just put those two equations, y equals 2x plus 1. Then the other equation, y equals x plus 3. Y equals x plus 3. And I can see exactly where these two lines cross. So in this one, for this first set, they cross at 2, 5. So I know this one's solution should be 2, 5. Okay. Now you would do the same for each of these and figure out where do these two lines cross each other, where do these two lines cross each other, and each of them should give you a solution. Next one. A local museum charges $25 per adult, $12 per child for admission fees. At the end of the day, the museum made $9,014 in total admission revenue, not including sales tax, and had a total of 450 guests. The system of equations below can be used to model the number of guests that were children, X, and the number of adults, Y. So we can see the two equations here. This two equations should make sense because they bring in $12 per child, $25 per adult, and the total number of dollars, 9,014 for the day. Also, the number of tickets sold for children and adults was 450 total tickets, total guests. All right. First, place a point in the graph representing the solution to the system of equations. Notice that one of the equations in the system has already been graphed. Then determine the approximate number of guests that were children and the approximate number of guests that were adults on the day. So again, one thing I can do is just go to Desmos. Okay, so we got 12x plus 25y equals 9014. And then x plus y is 450. So I can go ahead and graph those here. $12x plus 25y equals 9014. Whoop. Something there, right? 12x plus 25y. Okay, very good. And then x plus y equals 450. Okay. Now you may have to zoom out quite a bit to see where these two lines cross. And there you go. And now remember, X is the number of children. So in this case, there was 172 children. And Y, the Y coordinate, represents the number of adults. So the number of adults was 278 adults on this particular day. Okay. Which system of equations intersect at the point A in the graph? So it looks like my point A is at -2, 1. So my x coordinate is -2, my y coordinate is 1. So -2, 1. What you want to do is plug in this point into both the equations. The correct answer would have both the equations working for that point. So you'd replace the x coordinate with -2, the y coordinate with 1, plug it in and see if you get a true statement. Okay. Drag the tiles to the correct boxes to complete the pairs. Not all tiles will be used. Match each graph below with the correct solution or correct number of solutions to a system of equations. Okay. Remember, when we're looking at for a solution, we're looking where do the two lines cross each other. Okay. In the case of these parallel lines, do these cross each other at all? Well, no. So which of these would be the correct location where they cross? Well, no solution there. Okay. Infinitely many solutions is when the two lines are actually the same line. Here you can't see it, but both lines are on the same here. So that's infinitely many solutions. And then here, just looking for where the two lines cross. So which coordinate point is that? Okay. Well, with that, I hope you found it helpful. Please like, comment, subscribe. If you have any questions, comment them below. And well, I hope that made sense. And I'll see you guys next time. Take care.